Understanding artificial gravity. There are two things that will make it impossible to colonize space if they are not properly dealt with: cosmic radiation and low gravity. Every viable colonization site being considered right now, Mars, the Moon, Titan, Ceres, is a place where the natural gravity is much lower than Earth normal. The gravity on Earth is measured as an acceleration toward the center of the planet. The Earth has a radius of 6,371 kilometers. The average force of gravity on Earth's surface is 9.8 meters per second squared. This means that you will feel a force pushing you down on the Earth as if you were in a spaceship in empty space and the ship was accelerating at 9.8 meters per second squared. This acceleration means that at the end of the first second, your ship is traveling 9.8 meters per second. At the end of the next second, the ship is traveling 19.6 meters per second. After the third second, it will be going 29.4 meters per second. It is this acceleration that gives you the exact feeling of gravity on Earth. Simply going fast in space does not produce a gravity effect. Changes in velocity, acceleration, or deceleration produces this effect. The Expanse uses constant thrust to show normal gravity on their ships during spaceflight. Though this is a much more practical method of producing a gravity effect than gravity generators on Star Trek, or just ignoring the problem like most shows, in the Expanse they have an Epstein drive, something we do not have. So we'll have to find another way. The astronauts and cosmonauts on the International Space Station live in freefall, feeling no gravitational force. This does not mean there is no gravity at the altitude it orbits, which is about 320 kilometers. The gravity there is almost the same as the surface of the Earth, but they are moving horizontally at a tremendous speed. This causes them to fall in an arced path. This path happens to be the same arc as the curvature of the Earth, so they constantly fall around the Earth without ever hitting it. Living in zero-G is very bad for you. You very quickly suffer significant bone loss, muscle loss, and fluid redistribution. Your heart gets weak, and at times your blood actually flows backwards through some veins. Your head fills with fluid, increasing the pressure on your eyes and causing vision problems. These effects are not all resolved with exercise and resistance training. Many astronauts are incapacitated for several days on arriving to the space station because of nausea, vomiting, and other vestibulocochlear effects. The only way for humans to safely colonize space is to have artificial gravity. The best way to produce artificial gravity with modern technology is using centrifugal force. When an object is spinning, a force will be generated moving out from the center of spin. This force is centrifugal force. To keep things from flying away, they must be held back by an opposing force. This is the centripetal force. The centripetal force is felt by the structure of your ship. It is like hanging on to a rapidly spinning merry-go-round. The centrifugal force is what you feel trying to pull you off. The centripetal force is your arms pulling in the opposite direction. So on a spinning space station, the colonists walk on the inside wall of the station, feeling a force pressing them to it. This again is the centrifugal force. The cables and spokes of the station will exert a force toward the center, counteracting the outward force. Again, this is the centripetal force. If the station spun too fast, it could tear the spokes apart and everything would go flying out. This type of artificial gravity was first described by a brilliant self-taught scientist in Russia named Konstantin Tsiolkovsky. He solved the rocket equation that allows us to plan all spaceflight and worked out the principle of a rotating station producing artificial gravity. Wernher von Braun brought this concept to the attention of NASA and the world with Walt Disney when they developed the concept and created models representing the station. This is often called the von Braun station, but in all fairness, they should be known as Tsiolkovsky stations. A large rotating space colony could have many shapes, from the spinning wheel design to a rotating cylinder. This was depicted very well in the television show Babylon 5. When you are designing an artificial gravity system, the two most important questions are, how big can I make it, and how many rotations per minute can my colonists stand? The smaller the radius, the faster your ship must spin. To make a SpaceX Starship have normal Earth gravity of 1 g on the inside of its hull when spinning on its long axis, you would have to spin it at 14 RPM. This is pretty fast. The steel construction should not have a problem with it, but the passengers might. We must differentiate between the highly trained astronauts who are tested and excluded if they experience too much motion sickness, and the average colonist, who probably gets seasick. If we install inflatable habitats and extend them from the starship, say we use Transhab, the upright inflatable habitat designed and abandoned by NASA and later purchased by Bigelow Aerospace. These were 11 meters tall. If we put the living quarters at the bottom of these, we would get a radius from the center of the ship at 15.5 meters. At 15.5 meters, we get 1 G at 7.6 RPM. Our colonists may be able to tolerate this, but it would be unlikely. There would be a significant Coriolis effect, meaning the spin at your feet would be different than the spin at your head. Any rapid head movements would almost certainly cause severe nausea. Children are still accommodating to their environment and may adjust perfectly to the spin effect, but then feel extreme motion sickness on planets. It would be best to keep the spin at about 2 RPM. This is unnoticeable to almost everyone. This would give a radius of about 223 meters if you wanted to generate 1 Earth gravity. This is a big space station. It would have a circumference of 1,400 meters, or 1.4 kilometers. But could we get by with less gravity? If our colonists were going to Mars on their Transhab-equipped starship, we could adjust them to Martian gravity on the way. Mars gravity is 3.71 meters per second squared, which is 38% that of Earth. To produce this much gravity, the starship would only have to be rotated at 4.7 RPM. This would be easily manageable to adult colonists going to build the infrastructure for the general colonists to come later. By the time you are transporting children, you need a true Aldrin cycler with a radius of at least 233 meters and spinning at 2 RPM, giving 1 G. During the 8th month flight, you could slowly adjust the rotation speed while everyone is sleeping, so it slowly goes down to 1.2 RPM. This would give a centrifugal acceleration of 3.71 meters per second squared, which is Mars gravity, adjusting everyone to the lower gravity en route. So if you want artificial gravity on a ship, you're going to have a big ship. Any gravity at all would probably help tremendously, as blood pools in the head and even flows backwards in zero gravity. This is not healthy. The SpaceX Starship could generate Martian gravity at a reasonable RPM for adult astronauts. A large rotating ship will be needed for children. In summary, the only practical way to generate artificial gravity with current technology is by rotating your ship or colony. The larger the radius, the slower it can spin to generate a specific gravitational force. Astronauts and carefully selected colonists could withstand high RPMs, maybe as much as 14 RPM, without serious consequences, so they could get by with a smaller ship. The general adult population probably cannot withstand more than 4 RPM without significant distress. Children should not be subjected to more than 2 RPM, as it could impair the development of their vestibulocochlear systems. Any gravity is better than no gravity, and the medical consequences of zero gravity are severe. But the question of low gravity accommodation does not end with the voyage. We also must consider what will be done when the person arrives at the moon or Mars or on an asteroid. It will be necessary for people to live on high-speed train habitat to allow proper childhood development. No one knows if it's safe to raise children in lunar or Martian gravity. It would be completely unethical to subject children to this without finding out. Pregnant women and children up to the age of perhaps 18 or 20 would need to live on an artificial gravity producing train with a radius of about 1 kilometer. This train could then go around at about 1 RPM, producing 1 G of normal Earth gravity. All the colonists could live on this train, boarding and unboarding using a parallel track that catches up to, docks with, and then undocks from the train. They would work on the Martian or lunar surface and then come back to their artificial gravity train for the rest of their day and night. This would allow cardiovascular, muscle, and bone reconditioning and should vastly extend how long people can safely live and work in a low gravity environment. Thank you for listening and stay safe.